Okay, this video, I'm going to take a little time out of my day to actually just do minute amount of educational on vacuum and microns and a vacuum gauge and what a micron meter is and what it's capable of. I've made videos of this, but it seems like there's some people with many years of experience, even decades, because just had a recent comment of somebody who said, what a piece of shit the gauge is, because they can't get below 700 microns and it keeps leaking, and you know, they're trying to pull on refrigeration, they don't like leak and stuff like that. Well, in the first case, oh, and the other thing is, he is a red seal journeyman. Well, if you're a red seal journeyman and you're trying to pull deep vacuum and do a vacuum decay test through refrigerant hoses, you are nothing more than a little Girl Scout who hasn't even read the first page on a manual on performing a vacuum decay test. So the Red Seal Journeyman certification is nothing more than toilet paper to wipe my ass with. Okay, so we got that out of the way. So, what are the capabilities and how do you draw a real proper vacuum? Well, in automotive, we really don't care because we're not going to such low temperatures like in the refrigerations where you need to get a vacuum below 200 microns or so. And hold, not just get there and turn it off and allow it to go up. Not get there with the pump running and the gauge is still holding, seeing 200. That means absolutely nothing, because in the first place, you would never draw or even attempt to pull a deep vacuum through a set of gauges with so many possible leak sites with O-rings and seals and connections and stuff like that. It's just suicide. You wouldn't do that in the first place. Then you would never try to do it through rubber hose refrigeration gauge. Just the rubber, the hose itself, the material itself is a failure point for trying to draw a real deep vacuum. So you would never do that in the first place. But why are people trying to do this? Lack of education. So here's silicone, here's a rubber hose. This you do not draw. If you're attempting to do a vacuum decay test, you would lose just in the hoses alone, let alone your 100 feet of line set and your condenser coil and your 5-ton evaporator coil. This would make you fail right off the bat. You would never do that. So you would have a separate micron gauge like this, and you would have it on a commercial system. You'd either have it set up somewhere where there was a fitting for a pressure sensor, or you would set up, I don't have it here with me, I'm not prepared, but you would have a gauge with a ball valve on it that you can turn off, and you would have your gauge up there that you can ball off from your vacuum. So when you're through with your vacuum, you would have a valve right here and you would shut off the vacuum through your hoses. So just your micron gauge was isolated to the system itself, in no way, shape, or form attached to hoses. So take, for instance, in this situation here. So I'm drawing a vacuum on just the manifold. I have both the high and low turned off, and I'm just drawing in the vacuum, the micron sensor that's located inside here. It says 61 microns. That is at this point coming in here, and my system is contaminated with ester oil. I have ester oil because the last vehicle I did had ester oil in it. So I have a little bit of ester oil contamination in here, a little moisture. This is my limitation. I know for a fact when this is dry and I have this vacuum pump on, I could hit 30 microns. But I know there's contamination. This is my limitation right now. I know when I put this right on the end of this vacuum hose, I could hit 13 microns. And I know when I put it down here, this will go down to about 5 microns when I totally eliminate the hose and I just deadhead it right to a plate, right to the vacuum pump itself. Here's another vacuum pump. This one has a micron gauge built right inside of it before all this, and it's saying 99 microns down here on this one, and it is going through this refrigeration line. Well, this is a refrigeration line made out of rubber. This is a vacuum line made out of silicone that's never been contaminated with any kind of oils in it or anything like that. So let's take this and let me wake it back up, okay, and let's connect it to just this vacuum line here and see what we're going to get. and make sure I don't want that off. This is off. I haven't evacuated this system yet, so we'll get there. So let's hook up right to this. But one hand, no, one hand is not going to do that. Okay, so now we're going through a refrigerant hose that you would never even attempt, and I have to stress this because unfortunately people believe that you can do a vacuum decay test through refrigerant hoses. You're mistaken. You maybe accidentally misunderstood some wording that was put on the internet. Okay, so let's open this up. I have the high side off. Turn this one on, I have this on. We're at 60 microns at this point from this sensor in this manifold. Now let's open up this port going to that sensor. And by the way, let's do this too. Let's go one step further because I did open this just for you guys. Let me connect. There we go. We're a high pot, we're at 760 microns. We're at atmospheric pressure. That's why it says high P right now. So let's open up the vacuum to it. 1, 2, can I get that in the background at the same time? 1, 2, 3. Boom, I opened it. Now, did you see that jump up here in the gauge and you see how fast that's going down? Okay, let me kill this again. I don't need my thing on, it's going down. So we're down to 200. So we just lost just what's inside this line. Dropped it from the 65 that was up here, and we're reading 200 at this point here. 233, we're at 100 something. Those are the difference of 100 microns almost between here and here. Just this length of hose is making you lose, and this is a contaminated hose that has been used on air conditioning before. So right there, that will make you get a bad reading. Look way down here, 114 way down here just on this line. I don't have that one open. I just have it deadheaded right now. Okay, so that is what our loss is between here and here. We got nearly exactly 100 difference just in this one hose. Now let's do this. Let's shut it off. Let's shut our vacuum source off. And can I do this so we can see both of them? Can you see that? Kinda. I'm gonna shut the vacuum source off. Let's let the vacuum. Yeah, my camera's going again. I definitely got to get a new camera on my phone. Okay, I just shut off the vacuum. Vacuum is now shut off. Now we're gonna suffer from decay. You see how rapid that decay is going? I don't have a leak in my hose. I don't have a leak in my seals. This is just the moisture, and it's gonna stop. It probably might stop as high as 3,400 microns or so. But if it keeps going and I hold it here, and look how much higher this one is way at the end of the hose than this one way back here inside the unit. Eventually they'll stable out, and just the contamination of moisture and refrigerant that are absorbed into the coating of refrigerant oil in my hose will make the microns shoot up like this. And if I let them sit long enough, both of these will show the same number eventually. So let me go to the next thing there because I don't have time to do all this. And why is this? I must have this on energy saving mode because it keeps shutting down on me. So you see this? Let's go to here. There you go. There's the graph. You could see exactly when I turned on the port, where it went down at. Why can't I focus? Come on, focus on it. There we go. And you can see where it shot down, how fast it went below 500 microns. And then you can see where I shut it off. I shut the valve, I turned the vacuum valve off, and you can see how fast. And yeah, you see this little timer? It actually gives you the time and the microns. How I move that? You see that? You can actually graph out your micron. Now when I'm doing large commissioning on like a big VFR unit for an LG system and it's 60 tons or something like that, 20 tons, this is what I do over a 24-hour period of time. And I've made it a habit to record, and I actually put in a file for my receipts and my records and everything like that on every unit, how long I recorded, and I record the decay, and I let the decay go up, and I record it, put it in a little thumb file, and put it in with every unit I now do. That's something I started a couple years ago. Okay, so now let me close this off. Let's take this off so we could lose our vacuum. You'll see it. There we go. I just broke the vacuum. Boom. Now what we're going to do, we're going to take this and we're going to put it, and we're going to take it from the very far end. Now say I had a 5-ton condenser and evaporator on a residential, and I wanted the cheapest method to get the best system. Well, all you got to do is invest in one good hose to one vacuum pump and put it on one side, and you'll get a good result. Take just a tad bit longer. Okay guys, I might have to put your phone down. Let's see. How coordinated am I? I'm not very coordinated. Camera and doing this one-handed is not the right way to do it. Hold it. Gotta put the camera down. Sorry guys. Camera goes down. Alright. So now that's sturdily on there. So let me open it up to the system. So now I'm depressing it. I'm depressing the valve. Now this valve core, this is another thing HVAC guys don't know. The valve core in there, the size of the valve core head inside here is about the size of a number 2, that red pencil eraser, that diameter. That's how big that valve core. When it's a big piston, it's like a valve in a 454 Hemi. It's a big valve that gets pushed down. It's not a little tiny core, Schrader core, that's in residential or commercial HVAC. In automotive, it's a huge ass valve, so there's a big surface area. How much flow that can go through one of these is like 20 times more than a valve core inside a residential or commercial unit. And that's another thing, guys from HVAC in commercial and residential, they don't know that. So they see me do this and they go, oh, you're trying to draw a vacuum through a little valve core. You're an idiot. No, idiot. The valve core in here has 20 times the flow of anything that's in commercial or residential. Let's see. So I'm over there. I'm hooked up right here. You see right here? I have not depressed this to the system, and we're at atmospheric, and I'm on the high side. So let me open up. Yeah, you can see I decayed to 666 grams in this system with both the hoses closed. Just the decay. There's no leak. This is just moisture from my ester oil that's in here that's contaminated. Now I'm going to open it up to the vacuum source. There we go. And you see how fast the vacuum drops? That's how it should drop when everything is done correctly. And because I have a contaminated system, this will not go down below 30. If I had a clean manifold and I do this, it goes down below 30 instantly, just about. But I know my system and my equipment. Okay, so now I'm going to open up just the red high hose, just to this point, because it's not to the system yet. Let's open it up and see how bad our hose is. Let's see how dirty our hose is. So that was the hose, and this is how fast it's coming back down. And it'll eventually level out, and that'll tell me my rate of decay of my dirtiness of my hose. How dirty is my hose? It should go back down. Theoretically, if the hose was perfect, that 60 microns I had before when I opened this, it should go back down to 60. But this is not a perfect world, and this is an old used hose that you've seen me make this hose up with this coating on it for protection. You seen me make this a couple months ago, so you know how old this hose is by my previous video. When I put this protective shrink wrap on here with silicone grease, you can go back and research how old this hose I'm using. I use this every day on every job, and there we are. We're leveling out somewhere right around there. We can no longer hit that 60 microns. So now let's go one step further and let's open it to the system. And let me get this back here. I have to turn off. I got the energy. I must have the energy saver mode on here because it keeps turning off my screen, and I'm not going to go back in and turn it off though. So let's do this. We are going to watch this drop down as soon as I open this. It's slowly, because now it has to remove the whole entire volume of this automotive system. Now an automotive system compared to residential HVAC, let's go down to a 3-ton system. Compare a 3-ton condenser on commercial or residential to this. This condenser is about a 1/2 inch thick. Just my finger is almost thicker than I could lay on top of the thickness of this micro channel tube. And it's only 30 inches from here to here, 30 inches. And from down here to here, it's about 28 inches from here to here. That's it. That's your condenser. This is like a 1-ton system, a 1.5 ton system. The evaporator core is located right here. And the evaporator core is basically about this size or smaller than this iPad. That's how small that evaporator core is. So before this will ever affect this over here, it has to start removing that airflow. So let's remove that. Let's take a look. And let's turn this down and see what happens. There we go. I just put that down. And that is open. And why am I not getting anything? I must not be, nothing's happening here. So am I having a problem? Did I not go down all the way? I have the vacuum source open. I'm dropping in microns here, but I'm not dropping in microns there. I have that open. Houston, do we have a problem? And did I just catch it on video? That's cool. All right. I had it in there. See that? Nothing's happening over there. And I didn't hear nothing. There we go. So my stem did not go all the way down and hit. I didn't have it all the way. It didn't center on the valve core in there. Look at it drop. Look how fast that's dropping right now. Now, that's not 2 hoses. That's only 1 hose drawing for the furthest end. I'm way over here on the liquid line, and I'm taking my measurement over here on the suction line. This is a tiny system. 900. Now let me. Down here at the vacuum. So I have this one open. So we're reading under 200 microns right here. But we're reading 800 microns right here. And we're reading 3,000 microns here. 3,000 microns. Now if I had another micron gauge, which I do, I have my Fluke or my field piece, I can't remember which one. I could put another valve right here, and if we're reading 800 here and we're reading 3,000 here, I bet you if I put a micron gauge right here, it would read, oh, let's say 1,200. And then if I put another micron gauge right here, if I took this sensor out and I was able to put 1 micron gauge here and 1 micron gauge here, you'd probably see 1,200 here and let's say 1,600 right here after the valve. And then we have one here at the furthest point, it's at 2,600. Now as we get way down there, you can see it starts settling out. Now it's just time. This was an old system and it's highly contaminated with moisture because the shop left the lines. This shop here leaves the lines open to the atmosphere. And so this is PEG oil, PAG, and it is like ester oil. It absorbs moisture greatly. And it's saturated with tons of moisture. There's little residual refrigerant buried deep down in the oil in the compressor and stuff like that, very residual. Now this has been open to the atmosphere for a week. 2 weeks actually almost. I think I might have even done a video on the recovery. So now I'm fighting vaporizing off moisture. It's literally, if you can see, if these were glass and you can see inside the compressor where there's a little layer of oil and you can see the layer of the oil in the bottom of the evaporator, you would literally see it bubbling up and boiling. It looked just like frying oil for your chicken. You know when you have a little bit of moisture and you throw a piece of greens inside frying oil and the water boils off? This is what is happening inside this system and you can't see it, but a micron meter can read it and you literally can tell. So now let's do another thing. Let's Here's guys who are having a problem. They're drawing these fantastic vacuums. Oh, I'm drawing this great vacuum. Look, I got 700 microns in the system. I just had someone say they can't get under 700 microns in the system. Well, I'm stalling out here. And I'm stalling out. It's starting to really slow down at 7. And I could tell you this vacuum pump will beat the shit out of most other people's vacuum pumps. Because it has a capability of going down. It's not how many CFM. This has a capability of going down to 3 microns. And I timed out here. My video must be getting really long. Yep, 20 minutes. And so let's close this off. And come on, guy, open up. Let's close our vacuum source off. So we're not going to close the vacuum source off here because I know this is going to go over 1400, 2000. It'll fail every time because you got to be stupid to try to do a vacuum decay test through, okay, unknowledgeable. Let's not say here. Lacking education, lacking knowledge. You have to be unknowledgeable to try to do a vacuum decay test seriously through a set of used refrigerant hoses, even new refrigerant hoses. You would never do that. So let's turn it off at this point. We have an isolated system. Look at the hose. The hose is even collapsed. Look how flat that hose is. So let's isolate it by turning off the vacuum source here. And we're going to take refrigerant lines out of the loop. So we'll turn it off. This is killing it. And now we're going to see the vacuum decay. And now you see it going back up. Look at the numbers. Look at it slowly going back up. Now, if there's no leaks, this will probably stall. I don't have time to stay here and do this, but this will probably stall at about 3,400, 3,700, 3,200 microns. This will keep going up a little bit, and then the curve will go the other direction. It'll start flattening out, and it'll stop. And that is, it's reached its vapor pressure of the moisture trapped into oil and absorbed into the pores of the metal that has flashed out in the form of steam, repressurizing the tube. For this temperature, it will stabilize to a certain micron level and just stop. There's no leaks in the system. It just went up because there's no more vapor pressure available, and the heat we're at to boil off under that certain vacuum to release any more steam, and then it stabilizes off. All that means is you need more vacuum time. You need to change out the receiver dryer. This has a new dryer. This has new desiccant material inside this little tube here for you HVAC guys who don't know. There's a brand new desiccant. This is like changing your Sportland dryer. That's what that is. So it has brand new desiccant, brand new condenser, but in an old system. So let's see where we're at. And I'm gonna end this video right here so I could get on with work, because I'm sorry guys, but I gotta make money. I'm not one of these YouTubers who could spend hours editing and sitting at home and putting out YouTubes and do one job a day. All right, I'll get back to this on you later, and my lunch is waiting for me and I'm hungry. So I'll catch you guys later. And that's my vacuum. That beep is, this vacuum pump has a setting that when it is hit 500 microns for more than 30 minutes, at 30-minute point, the alarm, the beeper goes off and the motor slows down because it doesn't need to work so hard anymore. And that's what's happening right here, is that the internal alarm just notified me this has been under 500 microns for 30 minutes. All right guys, I'll see you. And you see this is stabling off. You see that slight raise at the way it's going? And it gives you the pull down rate, and eventually it'll go in. If I would have kept going, it'll go into the vacuum decay test and everything like that. That's for another video, another time. But just letting you know, nobody ever uses refrigerant manifolds with hoses and expect to pull and hold a manifold, especially if you're a red sealed certified master journeyman and you're telling me you're trying to use gauges and vacuum hoses. You might as well use toilet paper. I mean, that's just stupid. All right, I'll see you guys.